Alright, welcome back, NAMS class. We are in section 11.1. Once again, this is our third video of section 11.1. It revolves around things called percent change, as well as percent markup. You know what percentage things change by. We got a simple formula here, guys. It's really easy, but it gets messed up constantly. Be careful. The way we do percent change, we take the ending amount, subtract it from the starting amount, divide it by the starting amount, and then multiply it times 100. That's all we do. So, let's talk. In 2000, the population of North Dakota was 642,200. So this is the starting population. Moving on. In 2005, the population of North Dakota had decreased to this number. So that's the second one. That's the ending population. We want to know what the percent decrease was in between these years. So once again, it is end minus start divided by start times 100. So here we go. End in this case was 636,677. We subtract that from the starting amount, which was 642,200. We then divide that by the starting amount, 642,200, and multiply that result times 100. Once this process is done, it should come out to be 0.859. 0.859 is a percentage, guys. And what this means is that the actual population, and you should see it as negative 0.859, by the way. That just means it went down by 0.859%, but we don't actually write it as negative. The amount that it decreased was 0.859%. That's how we do our percentage problems. They're really easy stuff, guys. Let's look at a couple more examples. This one's actually real stuff. U.S. federal debt. You're going to notice here, probably have heard that the federal debt of the government has gone up a lot in the last 40 years, where here's a graph of it going up. Notice the actual amounts, and we are going to do, what we're going to perform here, is we're going to figure out the percent increase in the debt in between the years, okay? So again, the way we do percent increase is always end minus start divided by start times 100. That's what I'm going to do. So 1976 is going to be my ending because that's the later date. 1966 is going to be my start. So I'm going to look back. In 1976 there was 0.0 or 0.654. In 1966 it's 0.329. And understand this is in trillions of dollars. Trillions, a lot of money. So, how do we do our percent increase? N minus start divided by start times 100. So, what was the end? Well, in 1976, in the end, it was 0.654 trillion. We subtract that from the starting point, which was 1966, which is 0.329. We divide that by the starting point, which is 0.329. We multiply that result times 100 to produce the percentage on what it increased. To perform this calculation, guys, you should get 98.8 if you round it correctly. It's about 98.8%, almost 100%. And if you think about that, that makes perfect sense. Because if in 1966 it was 0.329, if you double that, it's almost 0.654. It went up by almost 100%. It almost doubled the actual debt. That's pretty large, guys. Let's look at the next examples, though. It's going to get a little more crazy. From 1976 to 1986. Well, if we're looking at this interval, the ending point is 1986. That's a later date. The starting point is 1976. So we go back and we find our numbers. All right, well, in 1986 it's 2.125. In 1976 it's 0.654. So those are the numbers we'll use in this case. So end minus start divided by start times 1,000. Once again, the end, the actual amount of debt in 1986 was 2.125 trillion. We will subtract that from the starting amount, which was 1976, which was 0.654. We then divide that result by 0.654. And once we get that, we multiply it times 100. In performing that calculation, it comes out to 224.9 if rounded appropriately. Guys, that's 224.9%. That means it went up by 224.9%. And if you think about that, that makes sense. It really does. You look at this number, 0.654, it went all the way up to 2.12. Like if you multiply that almost times 4, it gets you up there. It went up astronomically, 224.9%. That's what it changed by. Crazy numbers. One more example we're going to do here, 1996 to 2006. So here we go. This is the starting point because it's the first one. This is the ending point because it's the second part of the interval. Let's go back to our example. In 2006, it was 8.283 trillion. In 1996, it was 5.225 trillion. So those are the numbers we'll use. All right, start minus n divided by start times 100. Our ending point was 2006, and it was 8.283. Our starting point was 1996, which was 5.225. We divide that by the starting point, 5.225, and then we multiply it times 100. If done correctly and rounded appropriately, this should produce a result of 58.5. That's 58.5% that it increased by. All right, we have a very similar formula for percent markup and markdown, and it's kind of the same idea. It says selling price minus dealer's cost divided by dealer's cost times 100. Extremely similar, guys. It's kind of the same thing as end minus start divided by start times 100. It really is, if you think about it. Same idea going on here. So a paint store pays $6.50 for a gallon of paint, and then they're going to sell it for $11.75. What's the percent markup? Well, this is the ending or the selling point because that's what it's going to be sold for. That's the starting point because that's what they bought it for. And I'm going to perform my formula: end minus start divided by start times 100. So here we go. End was $11.75. Start was $6.50 divided by start, which is $6.50 times 100. In performing this calculation, it comes out, if rounded to the hundredths place, at 80.8%. Means they marked it up, 80.8%. Percent markup and percent change, guys.